Professor Gilbert, we really appreciate you taking the time to speak to the audience here in Australia. I've read that making an effective vaccine in 1 year is akin to landing a person on the moon. How apt or otherwise is that as a description?
I think that's a pretty good description. I believe it came from one of the scientists who work on the immunology of the trials, working in my research lab. It's it's appropriate, I think, because we needed to do so many different things and make them all work together at the same time and do it as quickly as possible. It wasn't just one thing that we had to do. It was very, very many different things, all coordinated, all working very, very quickly.
How did you manage to do it so quickly, given that at the start of the pandemic, I remember people saying, well, we've never had a vaccine done in that kind of a time frame?
That's right. Well, there are really two main reasons for that. One of them is that the way we make vaccines now, we use things that are called platform technologies. And these are ways of making vaccines that can be adapted to make vaccines against lots of different diseases. But a lot of work's already been done on the technology itself. It's been tested in clinical trials to make vaccines against other diseases. And I've been working on a vaccine against Middle East respiratory syndrome before the pandemic, and that's another coronavirus. So knowing that we could make that vaccine against a coronavirus put us in a very good position to make a vaccine when we needed to at the beginning of 2020. And there was a lot of work had already been done on how to manufacture the vaccine, how to test it, to make sure it was ready to use. We did all the steps that we would normally do to test and develop a vaccine, but we did them much more quickly because we cut out as much of the waiting time as we possibly could.
What kind of mindset makes a good scientist?
Oh, I think you have to be prepared to consider lots of different ideas all the time. We always have to think about what we expect to happen, but what other things might happen. We need to be prepared to review data that's presented to us and think all of the different possible explanations for that, and then come up with the most likely explanation and go on from there. So I think you have to be prepared to change your mind often if you're a scientist, and be continually thinking about what's happening and what the best thing to do about it is.
You mentioned that to get the vaccine happening, you had to be able to do a whole lot of things simultaneously. You're also the mother of triplets. How much do you think that's equipped you to be able to do a lot of things at once?
Well, I think what I learned from that is that firstly, you can probably do a lot more than you think when you're pushed, when the chips are down and you just have to get on with it, then people can. And I also learned that planning is key. Planning to avoid getting into difficult situations is a really good thing to do when you're looking after triplets, but also when you're planning a vaccine program. So yeah, lots of thinking what might go wrong and how can I stop it going wrong, planning ahead. That was really important.
When news broke of rare blood clotting associated with the AstraZeneca vaccine, it caused an overreaction in Australia and a disproportionate fear, which caused some people to delay opting for a vaccine. What did you make of all of that?
I think it's natural to be concerned about reactions to a vaccine, but there's now very, very clear evidence that taking the vaccine is much safer than getting infected with COVID. You're much more likely to have blood clots if you get infected with COVID than if you take the vaccine. The risk of these serious adverse events is really very, very low. And with a good monitoring system to pick up anything that may go wrong in the small number of people it happens to, then the risk is reduced even further. So it's really important that people look at the whole picture. With the Delta variant, which is spreading so rapidly, it's going to reach everybody who's not vaccinated and also reach those people who are vaccinated. And even if they then get infected, they tend to have a much milder disease. They're protected against hospitalization. So really, we can't hide from this virus anymore. Initial plans were to try to eliminate the virus. That's not going to be possible with the versions that we have spreading now. We have to be prepared to meet it and to deal with it, and that means vaccination.
Do you think people will end up having to have yearly coronavirus boosters?
I don't think everybody will. I think that the most vulnerable, the oldest members of society, those who are immunocompromised, are going to need regular boosters. But for younger people, we normally see good maintenance of immune responses. So there may be a first booster program, but I wouldn't expect it to happen every single year. We're going to develop long-term immunity to this virus, as we have to other coronaviruses that circulate every year and infect us and just give us a cold, because we get exposed in childhood, we develop our immunity to it, and then it's not really a threat to us anymore.
What do you think are the key lessons from this pandemic for the next one?
I think we should have been better prepared, and we now need to learn those lessons. Being much better prepared with diagnostics is one thing, quite apart from vaccine development. If we can't track the disease, it's very difficult to know what's going on and how best to react to it. And I do remember in the UK, we were seeing a few cases reported, and then all of a sudden it just seemed to be everywhere, and we didn't have the ability to follow that. So being ready with diagnostics is something that we want to be better prepared with in future. And for vaccine manufacturing is the other big thing. We can develop vaccines, but we have to make them in very large quantities. And so we need a lot of vaccine manufacturing sites that are ready to go and able to switch to make a new vaccine when required. So there needs to be an expansion of vaccine manufacturing around the world.
Have you had much time to reflect on what you and your team have done for the world? Because you ultimately will end up saving millions and millions of lives.
Well, we still think that there's some way to go. We want to get the vaccine to many more countries in much larger numbers. There's a lot of Africa that hasn't received any vaccine yet, so the job's certainly not done.
What was the Wimbledon ovation like?
Well, that was a big surprise because I didn't know that it was going to be announced that we were in the Royal Box. I was there with many representatives of the NHS as well as other people who worked on vaccines, and we thought we were just there to watch the tennis. And then it was a surprise to be announced, and then obviously to receive a standing ovation was absolutely marvellous. But I wasn't expecting that to happen.
Well, it's been an absolute privilege to talk to you. Thank you so much for everything that you've done.
Thank you very much.
Hi, I'm Lee Sales. Thanks for watching this story. If you'd like to watch more of 7:30's stories, they are on the left of your screen. And tap on the button below to subscribe and get the latest from ABC News.